Good morning, students. Today we will discuss about the fuel cells. Now, what are fuel cells? The fuel cell is defined as a galvanic cell in which the chemical energy is contained in a readily available fuel. Oxidant systems is converted directly into an electrical energy by means of an electrochemical process in which the fuel is oxidized at the end. So it's a system where the fuel is burned continuously and the energy liberated as a burning of the fuel is completely converted into mechanical energy, then to an electrical energy. Now, a fuel cell essentially consists of the following arrangement. The fuel cell is a fuel electrode, electrolyte, or an electrode oxidant assembly in which at the anode the fuel undergoes an oxidation. The fuel undergoes an oxidation at the anode and giving rise to an oxidation product plus liberating an n moles of an electrons. Now, in this system, the fuel is burned and upon burning the energy liberated is converted into an mechanical energy then to an electrical energy. So the from the one end the fuel is continuously supplied and the other end the electrical energy as well as the product of the combustion, that is the carbon dioxide and water, is taken out. So at the cathode the oxygen gets reduced. So now advantages of the fuel cell. Advantages is energy conversion rate is high because here the energy is not stored in the cell. And the energy is supplied in the form of a fuel, and upon burning the energy is liberated and that energy is converted into electrical energy. So continuously from one end the fuel is supplied, from the another end the electrical energy is derived. So the operates silently. The fuels used are not expensive, so it is a very less expensive fuels are being used. High energy density you can obtain, the power density will be high or current density will be high, and produces the harmless byproducts. So the harmless byproducts is the product of the combustion, that is carbon dioxide and water, that is the byproducts which are getting from out of the fuel cell. Now recharge of the cell is not required. So the it is one of the very important criteria of a fuel cell where recharging is not required. From one side, input side, the fuel is supplied, and from the output the product of the combustion is removed as well as the electrical energy is derived. Limitations of the fuel cells. When you look into the limitation, power output is moderate power output. Electrodes are costly, and the fuels are to be stored in tanks under high in the batteries. But the fuel cells do not need any charging. So the advantage is that the fuel cells does not need any charging process. Now the electrodes are cheaper, but it will be consumed. Anode is continuously consumed in the conventional cell, and here electrodes are costly but not consumed. And in the fourth difference, the reactant and the products form an internal part of the batteries. So the reactants and the products both will be located inside the batteries in the form of an active materials, and reactants are continuously supplied and the products of the combustions are continuously removed. So reactants and the products are not the integral part of the fuel cells. And the fifth difference is the waste product in a battery may be harmful. So the less eco-friendly batteries are less eco-friendly. The waste products in a fuel cell are harmless because the product of the combustion, that is carbon dioxide and water, is not harmful. Now the first fuel cell is methanol-oxygen fuel cell. So the prerequisites for the methanol-oxygen fuel cell. Fuel is a methanol added with sulfuric acid, and an oxidant here is an oxygen is an oxidant. Electrodes are made up of either platinum or platinum electrodes or an graphite electrode. Inert electrodes are used, and electrolyte is the sulfuric acid. sulfuric acid, dilute sulfuric acid is used as an electrolyte. Now in this fuel, methanol-oxygen fuel cell, the methanol is mixed with the appropriate amount of dilute sulfuric acid is inserted into the anode, and once the methanol is inserted into the anode, a methanoate anion will be formed, and that methanoate anion will start moving from anode to cathode. So in order to retard the diffusion of this methanoate anion, a membrane is inserted close to the cathode to diffuse the or to retard the migration of methanoate anion coming from anode to cathode. Now the oxygen is applied at the cathode. Now, as soon as the oxygen will be supplied at the cathode, methanol mixed with 3 to 5 normal sulfuric acid is supplied from the anode. So the construction is it consists of a platinum or an graphite electrodes made as an anode and cathode. The oxidant is an oxygen which is applied at the cathode, and the fuel is a methanol. Methanol is mixed with the sulfuric acid is inserted from the anode. So once the methanol is inserted from the anode, you know very well the methanol get oxidized in presence of an oxygen. Now the methanol will convert first in the form of a methanoate anion to in order to retard the diffusion of or slow down the migration of methanoate anion from anode to cathode. A membrane is inserted close to the cathode. Now the reaction in order to so at the anode you know that methanol is inserted. Now the next fuel cell is solid oxide fuel cell, and it is generally called as an SOFCs. So this is also referred as a high temperature fuel cell. So where anode material is a nickel doped with yttria. So nickel, appropriate amount of nickel is doped to an yttria doped yttria stabilizer zirconia YSZ. YSZ is yttria stabilizer zirconia. It's a powder. In this powder, appropriate amount of nickel is also doped, 5%, 10%, 15% likewise. That material is made as in the form of an anode. Cathode is a lanthanum magnetite, LaMnO3. This is called as lanthanum magnetite, doped with appropriate amount of strontium. So the anode is nickel doped with YSZ. YSZ is a yttria stabilizer zirconia, and the cathode is lanthanum magnetite, that is doped with appropriate amount of strontium. Strontium is doped to lanthanum magnetite, which is made in the form of a cathode, and the fuel is hydrogen. Hydrogen is used as a fuel, and the oxidant is an oxygen is air, or the pure oxygen is used as an oxidant, and the electrolyte is the yttria stabilizer zirconia. The appropriate amount of yttria will be stabilized with the zirconia. That powder is used as a electrolyte, and the temperature of operation of the fuel cell is 600 to 1000 degrees Celsius. So these are the prerequisites before making or constructing the solid oxide fuel cell. So the anode, once again I will tell, anode is nickel doped to an yttria stabilizer zirconia. Cathode is lanthanum magnetite doped with appropriate amount of strontium. Fuel is an hydrogen. Oxidant is an oxygen. Electrolyte is a yttria stabilizer zirconia, and temperature is 650 to 1000 degrees Celsius. Now when you look into this construction, the anode material is placed and cathode material is also placed. In between a yttria stabilizer zirconia is a solid ceramic is used as a electrolyte. So both anode, cathode as well as the electrolyte is in the form of a solid, porous solid. In this porous solid, hydrogen is supplied at the anode, which undergoes an oxidation in presence of an oxygen, and when hydrogen and oxygen will combine and it forms a product, the H2 plus O2, and given rise to an water as the byproduct, and excess of oxygen which is supplied at the cathode is removed from the another end, And during this, the combination of hydrogen, the burning of hydrogen and forming water, during this combination, the electrical energy is derived out of the system. So the nickel stabilized, nickel doped with yttria stabilized zirconia is made in the form of an anode, and strontium doped with lanthanum magnetite is made in the form of a cathode. And in between, the yttria stabilizer zirconia is used as an electrolyte, and the whole assembly is kept in an sandwiched together, and from the inlet of anode, hydrogen is inserted, and from the inlet of cathode, oxygen is also inserted. Now the reaction at the anode, the oxygen will be coming, oxygen undergoes reduction, oxygen undergoes oxidation. So the oxygen immediately converts in the form of an O2 minus, and this oxygen will reacts with the hydrogen which is coming from the anode and forms a water with the liberation of two electrons. So at cathode, half molecule of oxygen, the oxygen is coming from the cathode, so the oxygen will react with this formed two electrons and giving rise to an O2 minus. So at the cathode, oxygen undergoes the reduction by accepting two electrons and generates O2 minus. This O2 minus combines with hydrogen coming from the anode and forms a molecule of water and regenerate these two electrons. So the net cell reaction, if you want to see, hydrogen gas combines with half a molecule of oxygen giving rise to water. So as I explained, solid oxide fuel cell is made up of an anode which is nickel doped with yttria stabilizer zirconia, and is a solid ceramic, and electrolyte is also a solid. Electrolyte is yttria stabilizer zirconia, and cathode material is strontium doped to lanthanum magnetite, and at the anode, hydrogen is inserted in the form of an active fuel, and this hydrogen undergoes oxidation in presence of an O2 minus. This O2 minus will be generated at the cathode when oxygen undergoes reduction by accepting two electrons and giving rise to O2 minus. Now this O2 minus combines with hydrogens and forms molecule of water with the liberation of two electrons. So it's a when you look into net cell reaction, hydrogen combines with an oxygen and forms a molecule of water. So during this process, the electrons will flow from anode to cathode, and that electron will be taken out into an external circuit for necessary. So advantages is that since it operates at high temperature, and the reaction between hydrogen and oxygen gas, both reactants are in the form of a gas, and they combine very easily. Gas can combine with another gas very easily, and that's the reason you get a high efficiency. So the high power efficiency or high current efficiency and long-term stability, and the long-term stability of the anode cathode active materials, as well as the YSZ, that is the yttria stabilizer zirconia. Fuel flexibility. Fuel flexibility is that at the 650 to 1000 degrees Celsius, the solid fuels will become amorphous and exist in the form of a porosity. In that porosity, hydrogen and oxygen can easily combine and form a molecule of water. So that is what is the reference is called as a fuel flexibility. And low emissions. So there is no, of course, there is only the formation of water. So there is no emission at all, and that is what is called as low emissions and low cost. So the cost is the hydrogen. Other than that, it's a low cost fuel cell. Now disadvantage is that since it operates at a high operating temperature, so operating temperature will be 1000 degrees Celsius, which results in longer startup times. So in order to start this fuel cell, first the anode, cathode, and the electrolytes will be heated to 600 to 650 to 1000 degrees Celsius. That is, so initial heating will take up some time. So that is what is called as results in longer startup times and mechanical and chemical compatibility issues. So the mechanical compatibility, in the sense, the fuel cell should be made up of the heat resistance materials. The stainless steels, or specially designed stainless steel should be required. That is what is called as mechanical. And the chemical compatibility is that the stability of the anode material, that is a nickel doped to yttria stabilizer zirconia, as well as the lanthanum doped to lanthanum magnetite doped with appropriate amount of strontium. So the chemical compatibility issues are the disadvantage